I used to use and which are really good. So we'll discuss about those visualization tools, and apart from that, later after that, we'll discuss about recursion versus iteration. What is iteration? What is recursion? How it is different, and which one to choose when. Couple of a table I've made, yeah, that will refer, and then we'll also discuss about couple of variations of recursion, like types of recursion, tail recursion, mutual recursion, or something like that. We'll discuss about that, and then I'll give a quick glimpse of one of my favorite topics in DSA, that is known as dynamic programming. We'll discuss a very brief, like one slide on it, as yeah, and then I'll also share a couple of resources with you, which you can refer very free, like free. Everyone, most of you already know, but most of you would not be knowing. Okay, so we'll share that with you as well. So yeah, that's the content for today, and let's see how much we can finish, and yeah, we'll have a good time the next few hours. Yeah, so yeah, cool. So basically, what is recursion? Okay, what is recursion? First of all, I'll say recursion is a topic where half of the people leave studying DSA, according to me, right? They start studying data structures and algorithms, but after recursion, 50% of them leave studying data structures and algorithms. That is my definition. But yeah, let's speak about a formal definition of recursion. So basically, it's a very simple language I'll talk about. It's a programming technique. Okay, it's a programming technique where a function calls itself. Okay, where a function calls itself to solve a smaller instance of the same problem. Okay, let's say we have a big chunk of a problem. Okay, we have a big problem. Okay, what we do is we have a function to solve that big problem, and that function calls itself with a smaller part, that, hey, can you solve this smaller problem first? Can you solve this smaller problem and give me the answer? The bigger function will tell. Okay, and then we will use those small answers and combine and then make our answer. Okay, so basically in simple words, yeah. So basically, recursive functions, as you can see, break down complex problems into simpler, more manageable, and sub-problems. Yeah. So basically, if we have a big complex problem, what recursion does is, okay, breaks it into smaller problems, which can be managed easily, which can be managed very easily. Okay, and those small problems, when you solve those each sub problems and you combine the answer, you're automatically, what happens is the bigger problem that you got, that gets solved. Okay, so that's how recursion works, and a basic intro to that. Now, what is the purpose of recursion? What is the purpose of recursion? So it simplifies, as it says, it simplifies problem solving. Yes, basically a lot of problems, okay, a lot of questions in DSA or in computer in software engineering, SDLC, okay, software development lifecycle. What happens is a lot of problems we can solve, but recursion makes it more intuitive to understand and easy to solve. Okay, due to recursion, what happens is those problems become very intuitive and easy to understand. This is the first thing. Expressiveness, the second thing. Okay, so what happens is we all of us have studied principle of mathematics induction and all of mathematics induction, right? If it is true for I is equal to 1, if it is, then it is true for I is equal to k, then that we prove, right? So recursion follows similar things only. Okay, what happens is, as I mentioned before as well, we have a bigger problem, and what we do is we try to solve multiple smaller sub-problems, okay, and then combine the answer or use those solutions of smaller sub-problems and find our answer. Okay, and we find our answer. Okay, so what makes it? It makes it more readable and simpler to understand. It expresses more. Okay, this recursive function or recursive solution, whatever you have, it expresses more about like how you have written it. Okay, about how you have written it. Now, a very simple example that everyone must be knowing is factorial. Okay, factorial. What is factorial? Factorial of an n is equal to n into n minus 1 into n minus 2 into ... till 1. That's it. Okay, so basically, if you call factorial 5, that is 5 into 4 into 3 into 2 into 1. Okay, factorial 5. So similarly, you can see factorial, it is given over here. Okay, you can see the cursor. Okay, so diff factorial n, it's a recursively we have tried to solve it. Diff factorial n, okay, it's a function whose name is factorial, where we are trying to pass a variable called n. Okay, and if we have a base case first, if n is equal to 0 or n is equal to 1, return 1. Okay, can someone tell me what is the factorial of 1? It will be 1, right? And what is the factorial of 0? It is also 1. Factorial of 0 is also 1. Factorial of 1 is also 1. So that is why if n is equal to 0, then what will return? 1. Or n is equal to 1, then also will return 1. Else, let's say if factorial n is something else, right? N is something else like 5, 10, 20. Okay, then what will do? Then it will go to this second case. Else return n into factorial of.
1 second. Sachin, everybody is able to see the screen? Can you give me a reaction, everybody? Okay. Those who are not able to see the screen, can you just rejoin? And Sachin, we are getting some feedback to go a bit slow.
Go a bit slow. Sure. Cool. So basically, yeah, that is the where were we? We were discussing the example of factorial. Okay. So if there are two cases, either it can be n whatever value we are passing, it can be 0 or 1. Okay, that is one case. The second case is it can be other value. N is 5, 6, 7, 8, anything. Then what we'll do? We will break that. And do a function called to solve a smaller subproblem. How? See here. If you see, I'll just try to 1 second. Yeah. So if you see, return n into factorial of n minus 1. Factorial of n minus 1. Can you see this? Factorial, we are calling it again. It means that it is recursive. Okay. We are calling the same function again. That's why it is recursive. Now we are calling it for n minus 1. We are calling it for n minus 1. It means that we received n, let's say. Initially, we received n. Okay. What we have done here, we have broken down n into a smaller part, which is n minus 1. Okay. So we had n, and for example, it can be 5. So for example, diff factorial 5. Okay. And n is equal to 5. It will go in the else condition and it will write return, like it will execute like this fashion, in this way, return 5 into factorial of 5 minus 1. 5 minus 1 will be 4. So basically we had a question, find the factorial of 5, but we broke down into 5 into factorial of 5 minus 1, that is 4. Okay, so we broke down into smaller part, smaller subproblem. Okay, we broke down into smaller subproblem. Okay, I hope till now it is clear to everyone. Okay, very simple, where everyone starts recursion from. Okay, and a very simple example that everyone starts recursion. Yeah. So again, I'll repeat the whole slide. Okay, just quickly recap. Recursion is a programming technique where function calls itself to solve a smaller subproblem. Very important. Purpose, I told you, simplifies problem solving. Yes, it is. Expressiveness. Okay. And then I gave you the example of factorial calculation. Okay, factorial calculation, where n factorial is equal to n into n minus 1 factorial. Very simple. That we already know. Mathematically, we know, right? N factorial is equal to n into n minus 1 factorial. So that is something about some example of it. Okay. Now we'll move to the next slide. Yes. Yeah. Components of a recursive function. It is super important to understand. Okay, what are the components of a recursive function? It is super important to understand. What are the main components? Okay, so basically there are multiple components. The main components are two only. One is the base case. Base case means, okay, where the recursion will stop. Okay, where the recursion will stop. That is known as base case. And base case also acts as a termination condition to prevent, okay, infinite recursion. to prevent infinite recursion. Understood? I hope that is clear. And another one is recursive case or recurrence. Very important. Very important. Recurrence or recurrence relation. Okay. So basically, your problem, you have got a problem. Find the factorial of 5, for example. How do you break that factorial of 5 into smaller parts, like a smaller subproblem? Factorial 5 can be written as 5 into factorial of 4. This we thought because we know the formula in mathematics that n factorial is equal to n into n minus 1 factorial. N factorial is equal to n into n minus 1 factorial. We already know this. We already know this, right? So we got a problem. Okay, we got a problem, and then we broke down into smaller parts. We broke down into smaller parts, and that is the recurrence. That is the recurrence. Okay, and as you can see, recurrence means a part of the function where it calls itself to solve a smaller instance of the problem. Yes. So basically, we got factorial 5 to solve. Okay, we got it. Now what we will do, again solve again inside the function call, we will do call for factorial 5. No, we will try to break that factorial 5 into smaller parts, either factorial 4. Okay, I hope that is clear. Factorial 4 or factorial 3, anything, like whatever recurrence or mathematics allows. Okay, that is the two main important components of a recursive function. Now a very simple question can come from the people that, hey, how to decide what will be the base case, or how to decide what will be the recursive case? What to write here in the else part? What to write here in the else part? How to decide this? Or what to write here in the if part? What is this base case? How to decide? What to write? How to decide? How do I think that n is equal to 1 only or n is equal to 0 only? Why not n is equal to 4? How to decide this? Okay, a very simple approach that I follow, okay, and I suggest everyone, is to look for the smallest. What is the, listen again, okay? Smallest and a valid value for n. Okay, smallest possible and valid value for n. What, again I'm repeating, smallest and valid value for n. What does that mean? Smallest and valid, what does that mean? Okay, let me explain. If I pass -1, -2, will that make any sense here in our question? No, right? We are talking about the positive numbers only. Okay, so in the positive numbers, okay, starting from 0, okay, positive, all the 0 and onwards, right? So what is the smallest value which is valid, for which you know what is the factorial? If I ask you, tell me the factorial of -2, you might get confused. But if I ask you, tell me the factorial of 0, you will tell me easily, hey, Sachin, factorial of 0 is 1. If I ask you, tell me the factorial of 1, you'll say, hey, Sachin, I know. Factorial of 1 is also 1. I'll say, yeah, you are smart. Because you knew this is the smallest value for n and a valid, smallest and valid value for n for which you knew the answer. Understood, everyone? So in simple words, I'm repeating again. Smallest and a valid value, whatever value for n is possible, which is will be smallest. What is the smallest value of n possible and a valid? It will be 0. 0 is the smallest value for n, which is also valid. Okay, so this is how you define the base case. This is how you define the base case. Okay, I hope that is clear. Understood?
Guys, you can give reactions.
Cool.
If you understood it, give reactions.
Yeah. So smallest and valid value. Smallest and valid value. That is base case. Okay. For Fibonacci also, Fibonacci series, all of you know. So which is the first Fibonacci number? So you will say 0 or 1, 0. Right. The first 0, 1, then it starts 2, and then 3, and then it goes on. Right. So you know the first one is 0. First one is 0. You know that. You will not say first one is -1. So if I ask that what is the minimum value of in the Fibonacci series, you will say 0. So n can be 0 at the minimum. It cannot be negative. So it is the smallest and valid value. Smallest and valid value of n whatever parameter you have. Okay, factorial parameter, whatever things you have, whatever arguments you are passing, you try to look for smallest and valid value. That will be your base case. Okay, simple. Now, okay, recurrence. Now the recurrence. Okay, now the recurrence. Okay, n into factorial of n minus 1. How do we decide that for any question? Okay, you try to, what do you do? What you should do is, basically, if you have got any function, okay, in this case, it is factorial of n. Okay, so any function, and it will have obviously arguments passed in. So try to look for how you can legally, not legally, legally I mean, legally here I mean is which tends to solve the problem that you have given. Okay, so basically try to break that, okay, whatever function you have, okay, whatever function you have, try to break that into some problem such that that sub-problem will help. And there is no mantra to it or any formula to it that I will tell you and you can write. That you have to look according to the question. That the recurrence is totally based on the question. Okay, recurrence is totally based on the question. Okay, you have to analyze the question and then you have to write. So one question can come as how to improve writing these kind of things, how to get better at writing recurrences and factorials and all of that stuff. Like, sorry, not factorial, the base case and all of that is to simply practice. Is to simply practice. You can just practice and you can just, yeah, just improve, right? Improve your logic and all of that stuff. Okay, so these are the two main components in recursion: the base case and the recurrence case. And obviously, you have the function at the top. Inside that function, you will have these two things: base case and the recursive case or the recurrence. Okay, so these are the two main components of a recursive function. Okay, now how to solve a recursive question, and before that, how to identify a recursive question. Hey Sachin, you told that solve this way recursion, but what is the benefit if I'm not able to identify the question, right? Yeah, so actually first, how to identify where you can apply a recursion. First of all, wherever you have repetitive tasks to do, like iteration, okay, wherever you think for loop you can apply, there also recursion can be applied, or vice versa as well. Okay, any iterative problem can be done via recursion as well, and any recursive problem can be done via iteration as well. Then the question comes at why people build two things if you can do using one only. It all boils down to because recursion makes a lot of problems very much intuitive and simple to understand. If I have to find a path, I have given a matrix, let's say 2x2 matrix or 5x5 matrix. Okay, I want to go from point A to point B, and there are certain obstacles in between. I will use backtracking, and for that, recursion would be best. Why? Because it makes the solution very intuitive and easy to understand. It makes the solution very intuitive and easy to understand. That's why recursion is also there. Few problems can be done via iteration, for loops, while loops, for each loops, okay, all these things. And few problems, a lot of problems can be done via recursion. Now, this was the two things, okay, that you can do via iteration. So any problem you feel for loop or anything can be used, you can put recursion also there. So this way you can also identify. But major reason where you can identify recursion and apply recursive algorithms is where you have given that, okay, divide and conquer kind of problems, where you have given that, you have given a problem and you can break that into smaller chunks and combine those answers, and then you can give the answer wherever you feel it can be applied over there. This is the first. Or second, wherever you feel iteration can be applied, recursion can also be applied over there. Okay, wherever you feel recursion, okay, wherever you feel iteration can be applied, recursion can be applied there. First point. Second point is wherever you see that the problem can be divided into multiple parts, and you can solve those parts individually and combine the answers to get the answer of your main problem. There recursion can be used. Understood? I hope it is clear to everyone. Okay, cool. Yeah. So that is how you can identify recursive problems. Two things I told you. Okay. Now, how to solve a recursive problem? Okay, very important. Okay, very important. How to solve a recursive problem. Step one, I'll just go through the slides and then I'll explain you. Step one is you have to obviously understand the problem, right? You'll not straight up go for coding. You just have a paper pen with you. Just try to understand. Okay, carefully read and understand the problem statement, whatever the constraints is. Constraint is one of the most important part in recursive problems. Okay. Also, one more thing, guys. If you have lower constraints, this is the third tip. Okay. If you are solving, giving a lead code bi-weekly or weekly, okay. If you have given the constraints are very less, like n or array size is less than 100 or less than 1000 only, there also it might be a chances that recursion can be applied. So keep these observations in mind as well. Okay, if you are giving these kind of things, so constraints play a major role. So you can look at them also and think of applying recursion or something like that. Okay, and DP you can apply if you tabulation method. If you pick, you can do a n square in tabulation. You will find n square and that will run. But the n value, okay, it should be lesser. There also recursion can be applied if the constraint is a bit less. Okay. Now that is the first part. Understand the problem, see the inputs, output, whatever it is asking for, and the constraints. Okay, what are the constraints? Very important. Then identify the parameters. Very important in recursion, because you have recursive function in recursion, right? And in recursive function, you have parameters, you have to pass them. So basically, clearly define the parameters. Whatever parameters you feel, okay, that you have to use for the calculation. For example, here we had a parameter n. Okay, we used this n for calculation, n into n factorial of n minus 1, right? We use this for the calculation, right? So whatever parameters you feel are gonna be used, that you can pass in the recursive function. Okay, that you can pass in the recursive function. Then what you should do is define the recursive case first. This is the best approach. Do not define the base case. First, define the recursive case, because recursive case will also give you an idea about the base case. For example, here we are doing n minus 1. It means that if we have a number, any number, 100, 200, it will keep on decreasing by 1. So from 200 it will become 199, 198, and dot dot dot. It will go till 0 or 1. So it is going linearly, like 1 1 1 1 1. At some point it will reach 0. At some point it will also reach 10. At some point it will also reach, let's say, 100. If we have started from 200 minus 1 minus 1 minus 1, at some point it will reach 100. But what if we would have done n by 10 or n by 100? It will never reach 100 or at 1 or something. It will maybe sometime, if n is, let's say, 10 and we divide it by 100, it will become 0, right? So it will call for factorial of 0, right? So it called for factorial of 0. So basically what I'm trying to say is, basically this recursive case gives you a lot of idea about the base case or the case it will reach at some point of time. At some point of time. Okay. And okay, and then you have something called base case. Base cases, I already told you, whatever parameters you have defined in the function. See all the parameters in your function, whatever a, b, c, d, whatever 4 parameters you have, and you see what is the minimum possible valid value for a, for b, for c, for d. For each of them, you can apply an if-else condition or something like that to handle their minimum possible values. Okay, to handle their minimum possible values. Is it clear? Is it clear to everyone? I hope that is clear. Okay, 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 okay. Great. So that is how you can do it. Okay, very simple. And then you can define the base case. How to define the base case? I already told you. Think of the smallest, okay, smallest value of the parameter which is valid. You can't think that, hey, minimum, so it can be minimum n can be negative infinity or integer dot min value. No, we have to look for a valid also, like 0 or 1 or 2, 5 or something like that. Okay, so define the base case. Now, these are the few methods or way you can, okay, ask or approach to a recursive question. A very important thing that is written over here, which is my favorite, okay, have faith on the recursive case that will give the answer of the subproblem. In computer science, it is known as recursive leap of faith. What does it mean? Recursive leap of faith. It means that, see here, very simple, guys. You need to have a recursive leap of faith, because majority of the people I have seen, they start drawing, like what happens is, if you have tree recursion kind of thing, like one function is calling multiple functions, people what they do is they draw and all of that, which is very good, you should draw and try to dry run, which is absolutely good. But a quick way is, you think that this guy or this recurrence will give me the answer. I have trust on him, he's my friend, something like that. So factorial of n minus 1, let's say n was 5. Okay, n was 5. So 5 into factorial of 5 minus 1 will be factorial of 4. So I am assuming that factorial of 4 will give me the answer. What is the factorial of 4? 4 into 3 into 2 into 1. 2 3 just 6. 6 4 is 24. So I am assuming that factorial of 4 will give me 24. And when I will get 24, I will straight up multiply 5 into 24 and I will get 120. Understood? This is the best trick or way to apply recursion everywhere. Everyone, please listen carefully. You just trust the recursive recurrence or recursive function. You just trust the recurrence. It is called as, in computer science, a recursive leap of faith. You just have faith on that, hey, I have passed n minus 1. I have passed, let's say, 4 inside the factorial function. It will give me 24. I trust that. I trust that function. I don't need to draw 4, then 4 will call 3, then 3 will call 2. Okay, I don't need to draw. I trust it. That is known as recursive leap of faith. I trust it. Okay, and it will give me 24. And if you trust it, it will for sure give you 24. Okay, so this is known as recursive leap of faith. And most of the people get confused while drawing the recursive tree. Okay, it called this and it called this, but it was half executed, then we went back. That is really good. Okay, and one way to draw that recurrence is known as Euler tree. You draw upwards. Okay, Euler tree is a method you can just search on Google or somewhere. So basically, for recurrence, okay, Euler tree method. So basically, that is really good. But the thing is, if you trust the recurrence, if you have recursive leap of faith, then it will be good. Okay, I hope that is clear to all of you. You can react with thumbs up, thumbs down. Trust, recursive leap of faith. 4 good words. Okay, recursive leap of faith. Just trust it that it will give. You don't need to do for recursive factorial of 4. It will call factorial of 3. Call factorial of 1. No, you don't have to do it. Just have patience. It will give you the answer. And what you do, use that answer and take your current number. Let's say n. Take your current number n. Use the answer you got. Okay, that you trusted. And then what you do is multiply. Simple. Okay, recursive leap of faith. I hope that is clear. Cool. A very simple example, guys. A very simple example for you. Okay. It's called power function, power a to the power b or something like that. So we have given a function. Okay, we have given a function a. We have given a function, function named fn, which have a parameter a and n. A to the power n we have to calculate. A to the power n we have to calculate. Okay. How it will work? Let's see that. Okay. I'll just a second. Yep. Can you see this? This is the visualization tool. You can use it. It's called recursion.versal.app. I will share with you. Don't worry. I'll share at the end with you. Okay. You don't need to worry. So you can see here fn of 2,5. Okay. fn of 2,5. Can you see this? fn of 2,5. So 2 to the power 5, which is 32. We will run C. Okay. So basically, if I just, one second, if you're not able to see, I'll try to zoom it a bit. Yep, I've tried to zoom it. Just a visualization tool so that you understand it. So 2 to the power 5 we have to calculate. Okay, we will go in this. A is equal to 2, n is equal to 5. So is 5 is equal to 0? No. Is 5 is equal to, if 5 modulo 2 is 5 is even, is basically saying is 5 is even. No, it is not even. Then what we will do? Then we'll call this. Okay. 4, 2. What did we do? What did we do? A into A was 2, 2 into 2, 4, correct? And inside this, n minus 1 by 2 means 5 minus 1 by 2. 5 minus 1 is 4. 5 minus 1 is 4. 4 by 2. 4 by 2 will be 2. Okay, 4 by 2 will be 2. 4, 2. Then we move ahead. 4, 2. We go again inside this function. Okay, it's just for visualization. Generally, whatever problems you should solve, just have a recursive leap of faith. That will make your work 10 times easier. Okay, then you have a comma n. Okay, then you have a comma n. So that is 4, 2. A is equal to 4, n is equal to 2. Is 2 is equal to 0? No. Is 2 modulo 2 is equal to 0? Yes. So it will call a into a comma n by 2. A into a means 4, 4, 16. 16 into n by 2. N was 2. So 2 by 2 will be equal to 1. See here, 4, 4, 16. 2 by 2, 1, 16, 1. Then we'll move ahead again. So a is 16, n is equal to 1. A is 16, n is equal to 1. Okay, n is equal to 1. Okay, we'll see. Is 1 is equal to 0? No. Is 1 modulo 2 is equal to 0? No. Then what we'll do? We'll move ahead to the last one. So it will be equal to 16 into 16. See here, 16 into 16, a into a. 1, n was 1. So 1 minus 1 by 2, 0 by 2. 0 by 2 is 0. So it's 256, 0. 256, 0. Okay. After that, it will return 256, 0. So we will go here. A is 256, n is 0. If n is equal to 0, return 1. It has said here. It is the base case. See here, guys, see here. I told you, two things I told you, right? When you have parameters, think of the smallest value they can have. What value, smallest valued value of n can be? 2 to the power what? It will be 0 only, na? Any number power, what you will ask? 0 only. I am not talking about the negative. I'm talking about the positive and valid cases. What is the smallest power you can ask for any number? If the number is a to the power 0. Yeah. Or a to the power 1 also, mostly 0. A to the power 0 is what? 1. Any number to the power 0 is 1. Right. So if you have n is equal to 0, does not matter whatever the value of a is. You will just return 1. This is a simple base case. Now, how did this base case come? Because see here, we were dividing every time by 2. So we knew we are dividing it by 2, sometime it will come 0 only at the minimum, right? And what was the minimum, like the smallest valid value for n was 0. So that is why n is equal to 0, then return 1. N is equal to 0, then return 1. Okay, so 256, 0 will return 1 to 16, 1. Then 16, 1 will return 16 to 4, 2 back. Then 4, 2 will return 16, and then it will return 32. So fn 2, 5 return 32. This is the simple visualization that I did in front of you for function that calculates the power of a number, a to the power n, where a is a positive number, okay, positive, and n is also positive number. I hope that is clear to all of you. Is it clear, guys? Everyone? I hope that makes a bit clear. Cool. Great. Okay, great. So yeah, once again, yeah. So that is a simple visualization that we did for power. Simple another visualization let's do for Fibonacci as well. Okay, just give me 1 second. Fibonacci, very famous. Fibonacci is the everyone starts from that only, right? So yeah, Fibonacci, I'll just run Fibonacci. Okay, this is Fibonacci function. Okay, recursive function. Okay, it's tree recursion, and then we are calling for Fibonacci of 5, Fn of 5. It will make a tree-like structure. Can you see? I'll go one by one. It was just for animation and stuff. It looks cool, right? But I'll go one on one. Don't worry. Yeah. Okay. So basically, Fn5 starts running. It calls Fn4. Fibonacci here 5. N is equal to n is 5. Okay, n is 5. So here it is written if n is equal to 0 or 1 or something like that. Okay. So it will not execute that. It will go for Fibonacci of 4. Fibonacci of 4 will then call Fibonacci of 3. Fibonacci of 3 will call Fibonacci of 2. Fibonacci of 2 will call Fibonacci of 1. When Fibonacci of 1 will be called, Fn of 1, then this guy here, it will return that, hey, n is equal to 1. Yes, it is. Then return n. Then it will return 1. See, it will go back after 1. Yes, see here. Returned 1. And Fibonacci of 2 will also return. And Fibonacci of 2 will also call 0. Fibonacci of 0, see here. Because Fibonacci of 2, see here, n is equal to 2, then Fibonacci of 2 will call Fibonacci of 2 minus 1 plus Fibonacci of 2 minus 2. It means that Fibonacci of 2 minus 1, what is that? 2 minus 1 is 1. And 2 minus 2 is 0. Okay, so Fibonacci of 1 and Fibonacci of 0. It will call. So that's why Fibonacci of 2 has called Fibonacci of 1 and 0. Okay, and here also I will explain why dynamic programming is needed, where dynamic programming comes into play. Here, very simple to understand. Okay, then Fibonacci of 3 will call Fibonacci of 1. Okay, it will go back. Fibonacci of 4 will call Fibonacci of 2. Fibonacci of 2 will call Fibonacci of same thing. See here, Fibonacci 2. 2 will call 1 and 0. Here also it will call the same only. Yeah, 2 will call 1 and 0. And both will return, 1 will return 1, 0 will return 0. See here also, 1 will return 1, 0 will return 0. Okay, and I'll just move ahead. Similarly, it will happen for every, okay. Okay, so this is the recurrence tree or recursive flow. Okay, the tree, the flow, okay, how things went. Guys, a very simple example. Now I will tell you why dynamic programming is required. DP, dynamic programming. Okay, why it is required. So basically, what happens is, can you see Fibonacci of 2 is called here also? Yeah, 2, 1, 0. Yeah, 2 is later calling 1 and 2 is also later calling 0. It is also called here 2. 2 is again calling 1, again calling 0. Okay, here it is also called, again it is called 2. 2 is again calling 1 or 2 is again calling 0. Okay. Same with 3. 3 is calling 2 and 1. Here also 3 is called. 3 is calling 2 and 1. And 2 is later calling 1 and 0. Here also it is later calling 1 and 0. So basically, if we have already calculated 3 here in this position, why do we again need to call 3 here? This is the problem. If we have already called 3 here, why do we need to call 3 here? Okay, I hope that is clear to all of you. If same thing, if you have called 2 here, 2 is later calling 1, 0, why are we calling 2 here? That is the question. And this is why time complexity of these kind of solutions without DP becomes very lengthy. Okay, they are very slow if you do not apply DP. So what do we do in dynamic programming? A basic things like idea I'm giving you. If you have calculated 2, store it in some sort of memory. Memory, a data structure can be. It can be a data structure, a map or an array or a map, array, matrix, whatever data structure, hash table. You can store it and store this value in that. That whatever calculations you have done for 2, store it over there. And when next time you have got to calculate this, you just You have already calculated this and stored it in the data structure. You just fetch it from there. You just fetch it over from there. Same thing you can do to avoid the repetitions. And this is why dynamic programming is used heavily. Okay, and that's why this recursive and all of these things becomes very slow. And that's why we use dynamic programming. I hope that is clear to all of you. Is it, guys? Folks around here? Okay. So basically, I have made this whole tree in front of you to make easy for you to understand, guys. Okay. And 2 is called here also, then 2 is called here also. Why 2 is called here? Right. That is the issue. That is the issue, right? Why it is called here? If it is already calculated. So store it in some memory that, hey, I have that in memory. I have already calculated it. Why do I need to calculate? Take it from the memory, take it from the data structure. Okay. That's why we use dynamic programming. Okay. I hope that is clear with visualization, right? Now, I hope so. This function, it's easy for you to understand. If the n is equal to 0 or n is equal to 1, return n. Yeah, because if I'm asking for the 0th Fibonacci number, it will be 0 only. If I'm asking for the first Fibonacci number, it will be 1 only. So that is the minimum value for the Fibonacci series. Minimum, the smallest and valid value of n. The smallest and valid value of n for Fibonacci is 0 and 1. In this case, 2 smallest valid values. Okay. Same thing you have to calculate for others. A to the power b. What is the smallest value of, let's say, a possible or b possible? If a is equal to 0, whatever power you do, it will be 0 only. If a is 1 and you want to calculate a to the power n, whatever value for n it will be 1 only. Right? So this is the smallest valid value. Same for b. Okay, sorry, for n also. If n is equal to 0, so whatever number you have, you do a power 0, x to the power 0, it will be 1 only. Okay. Or if the value of n is 1 and the value of a is, let's say, any number, a to the power 1 will be a only. A for any a can be anything. 10, 100, 1000, lakh. So these are the small cases. Okay. You think of the possible smallest. Again, I'm repeating. Why I'm repeating multiple times is because people don't know how to write a base case. Whatever variables you have passed inside this, what is the smallest value for a possible? What is the smallest value for n possible? And you separately write if cases for that. Simple. Your base case will be handled. Okay. And a lot of things also depends on the question. You need to read the question properly and then decide. Cool. Now the difference between recursion versus iteration. Okay. What is the difference? So applications. Okay, first of all, before applications, let's discuss the definition. Recursion is basically function when it calls itself. Iteration is a set of instructions which are executed repeatedly using a for loop or something like that. Okay. You are executing a similar task multiple times. Okay. That is known as iterations. Applications, where it is used. Recursion is used mostly with functions. You apply recursion with function. Iteration is used with loops, for loops, while loops, etc. Okay. Recursion application is for functions and iteration is for loops. Okay. Now, termination. How does a recursive function terminates? Using the base case. The recursive function terminates using the base case. How does it terminate in iteration? When the termination condition will be met. For example, for int, how do we write a while loop or a for loop? For int I is equal to 0, I is smaller than n, I plus plus. When will the loop terminate? When I will be greater than or equal to n, then the loop will terminate. If the I is lesser than n, it will keep on going, right? So actually, the loop terminates when the termination, the condition what you have written, okay, which is the basis for the loop, whenever that is like falsified or that fails, that hey, it is not satisfying this condition, then your loop will fail. Okay, that is for the iteration. That is for the iteration. Okay, now usage. Used when code size needs to be small and time complexity is not an issue. Yeah, we can say that. So basically recursion codes are like 3-4 lines or something like that. Okay, there you can use, and also where you feel that here recursion will be more intuitive or easy to understand, readable. Here if you apply for loop, it will be confusing. Applying recursion will be readable. Okay, and time complexity is also not an issue. Why it is not an issue? Because the constraints are less. The constraint n is saying that n array length n is only up to 100. Okay, in that case I can go n square also. So time complexity is not an issue. I mentioned before as well, if the constraints are less, like the constraint is lesser, let's say arrays, let's say array you have given and you have to do recursion with array or something like that, and array size is n. Array size is n, and that n size can at max be 100. Then that's fine. 100 square, m square, you can apply. So time complexity is not an issue in that. Okay, so when to use it, you understood. Okay, used when time complexity needs to be balanced. Okay, so basically when we have recursion, what it does is each function call takes place in the stack memory. Stack. Okay, in our programming language we have stack memory, right? So the recursive calls take place in the stack memory. And a very famous error that happens due to recursion is called stack overflow. You might have heard this. Stack overflow error. It happens due to recursion. The stack memory fills completely due to infinite recursion calls. Okay, so that is also important, right? So that's why constraints are less, then we use that thing. Now here, if we want to balance the time complexity, and in recursion we have stack also, that memory limit it can give stack overflow and all those things. If we want to avoid those things, then we can use then we can use iteration. And you feel that iteration will be easier in this kind of question, and it will be more, it will make sense more to apply iteration there, because the code will be more intuitive and readable. Then obviously you should apply iteration. Okay, I hope that is clear. Okay, yeah, whatever makes it intuitive and readable and easy to understand, whichever code, because readability in software development, okay, code readability is a major issue. One guy writes anything, int a is equal to whatever variable, right? In companies, how other people will know what is that a variable? So readability should be there. Like good code writing is proper code writing should be there, right? And readability should be there. So to make sure that is also ensured, you can use iteration over there. Code size is generally smaller. It depends, actually. It's very back to say that it is always smaller. It depends on the question, but mostly it is smaller. Okay, mostly it is smaller. Time complexity very high. Yes. So the time complexity in recursive problems, recursion related problems, is generally high. N square. It can also go 2 to the power n sometimes. Yeah, 10 to the power n. It goes like that. Exponentials also it goes. Okay, that's why it goes, because your time, the constraints like n size, it's generally lesser. N will be 10, 20, like that in recursion. But in iteration, relatively you will have lower time complexity. O of n, okay, n into n and log n, n square, these kind of things will be n cube later, but it will rarely be exponential, never be exponential, right? Unless you have so many loops nested inside each other, and then it will cause a problem for you. N to the power n. If you have one loop inside that n nested loops, so n to the power n, it will be n square, n cube, then n to the power 4, then dot n to the power n. In that case, it can be. But yeah, mostly, relatively, it has lower time complexity. Okay, I'm talking about the iteration. And the recursion have high time complexity because the constraints are also low. Okay, now space complexity. The space complexity is higher than iterations. Yes, space complexity, because see, your recursive call stack, right? Like the stack memory which I discussed, There also recursive calls are being put. That will also take some space, right? That's why space complexity is higher. And here space complexity is lower because nothing like that is happening over here. Stack. Here the stack is used to store local variables when the function is called. Yes, stack, which I told about. Okay, stack memory. It is used to store the local variables when the function is called. Okay, in iteration, stack is not used. Guys, is it clear to all of you? Am I clear to all of you guys? The difference between recursion and iteration? Okay, great. Okay, thank you so much, everyone. Okay, cool. So that is a quick difference between recursion and iteration. We are just doing a friendly introduction and overview or revision kind of thing. But yeah, now this diagram, right? My favorite. Why this is okay. So you can see two pictures, one of Salman Khan, obviously, another also of Salman Khan. What does this signify? So it is actually recursion on the left hand side, iteration on the right hand side. Okay, recursion is very dangerous, man. So basically, if you do not apply it properly, it can consume your memory limit exceeded, and all of that, stack overflow. So many issues can happen. This guy, iteration is plain, man. He is a simple guy. You'll just give a proper termination condition. Yeah, it will occur. Time complexity, no issues. Space complexity also good. Everything is fine. So it is basically recursion on the left hand side, iteration on the right hand side. Okay, it's a simple pictorial meme. Cool. Variations, a very important thing to discuss. Yeah, what are the variations of recursion? Recursion are of so many variations can be here, but I've written 2-3. Okay, tree recursion, Fibonacci, simple tree recursion. It means that one recursion function is calling multiple other functions. So it becomes a tree-like structure. In visualization also you saw. See this. It forming a tree-like structure, right? It is forming a tree-like structure. So that's why it's called tree recursion. It's a tree recursion. This type of recursion, when a function make multiple recursive calls. One function is calling function A, then function B, then function C. A function X is calling function A, function B, function C, and function A is calling 3 more functions. Function B is calling 3 more functions. Function C is calling 3 more functions. So basically, it is forming a tree-like structure. So that's called as tree recursion. That's called as tree recursion. Okay, that is one thing. Tail recursion. Tail recursion is super simple. Fibonacci, sorry, not Fibonacci, factorial. Factorial is a tail recursion. Okay, factorial is a tail recursion. A form of recursion where the recursive call is the last operation in the function. Yes. A form of recursion where the recursive call is the last operation in the function. See, all these definitions are very standard. Okay. A lot of things might change according to the question. So you don't need to be concrete enough. What you can do is grasp the concept, theoretical, apply on problems, okay, practice more and more, and then you can see the variations of tail recursions, also variations. Okay. So nothing is concrete. You just have to apply as you see what the problem is asking for. Like what the problem is asking for, you apply accordingly. Okay, so that is tail recursion. Okay, tail recursion was simple factorial. Then you have mutual recursion, very, very good one. So multiple functions calling each other recursively. I'll show you. Checking if a number is even or odd using two mutually recursive functions. What is this? See here. Sorry, see here. Okay. So basically, 1 second. Yeah. So basically, 1 second. Yeah. So basically, what I'm trying to say is, you see this one. Okay. You see this, the third one. Is even, is odd. So is odd is calling is even. Is even is mutually calling is odd. And at some point, they will decide, okay, whether it is even or odd or odd. Okay. So if, okay, you can call any function, it will recurse, like mutually call the other one. If you call the function is even and pass a value, automatically it will call the other one is odd sometime. Or if you call is odd first, it will call is even. It is known as mutually recursive, mutual recursion. Understood? And the factorial, I already told you. Factorial was a tail recursion, and the Fibonacci was tree recursion. And this guy, this one is mutual recursion. Okay, mutual recursion. I hope that is clear to all of you. Is it, guys? Can you confirm, please? Is it clear to all of you? Mutual recursion, one is calling to another. Even is calling to odd. Hey, odd, you check this number. Hey, then odd will say that, hey, even, I have checked this number. You check this, whether it is even or not. So this will call, and at the end, when the base case will hit, it will, when the base case will hit, it will give the answer. Okay. So that is few variations of recursion. Few variations of recursion. Okay, so pretty basic questions I have included. I'll solve 1, 2 of them. Okay, 1, 2 from here, 1, 2 from here, and then we'll move to dynamic programming, a basic intro. Dynamic programming, basic intro. But yeah, before that, let's do one thing. My bad. Yeah, let's do one thing. Just
one more thing, Sachin. So we are already 1 hour. We'll have like few time.
okay.
We have like 10 minutes for the session, and then we have to take like 15 minutes Q&A.
Okay, cool. So let's do one thing maybe. Then let's skip to directly to dynamic programming. I guess these are pretty basic questions you can try on your own. Okay. So let's do one thing. Let's quickly jump to dynamic programming. Okay. Dynamic programming, one of the most important topics, and I was asked like a lot of questions from this dynamic programming while interviewing for Autodesk as well as Amazon before. Amazon asked a lot of trees and recursion based questions, ma'am. Amazon asked a huge number of questions on recursion, plus like not recursion exactly, but DP. I'll not say recursion, it was DP. Yeah. They asked a lot of questions in my interviews and Autodesk also. Okay. They asked a lot of questions on DP and recursion. So that's why I remember. Now, so just a quick intro. Okay. We are not going to full-fledged DP kind of thing. Just I have one slide, I guess. Yes, I have just one slide on DP. So I will discuss that, and then we are good. We'll go for the Q&A and all of that. Okay. So dynamic programming, one of the most important topics. So basically, dynamic programming is a paradigm, like important algorithm will say, okay, where what we do is we try to, first of all, it's an optimization algorithm, minimize, maximize, all these kind of things that we use DP for. What we do is dynamic programming is mainly used to eliminate the overlapping subproblems. Okay, the overlapping subproblems which I shown you in the tree recursion 2, 1, 0, it was calling same thing. So it is mainly used for eliminating the overlapping subproblems and breaking the problem into smaller parts. That is obviously recursion. So breaking the small problem into smaller parts, okay, and terminating or eliminating the overlapping subproblems so that the algorithm becomes more efficient. That is where that is the work of dynamic programming, and that is what it does. Okay, so basically it's a algorithm or a paradigm or something like that. Okay, algorithm, okay, which is used for optimization problem like minimize, maximize, these kind of things. Okay, and it is used majorly to eliminate overlapping subproblems. Okay, overlapping subproblems, and to break the problem into multiple smaller subproblems, and to use their answers to give a solid one answer. Okay, the main problem, which is basically what is recursion only. The main problem. Okay, I hope that is clear. What are the key concepts or the types of dynamic programming? So mainly the two types are, mainly the famous ones are memoization and bottom-up approach. Or I will say memoization and tabulation. What is memoization? So you keep your recursion over there, and inside the, so basically I'll show you quickly. One sec. Yeah. So you have this, okay, you have this function. Inside this, apart from n, you also pass an array or a map or a matrix, 2D grid. Okay, 2D array. You pass that also, and you store these values, and you store the result in that. Okay, and you store the result in that so that you can check later that whether this value was calculated or not. I guess I had one example. So this is what memoization works on. Okay, Yep, I guess it is visible to a couple of folks. Let me share this tab. Okay, I just wrote it in IDE. So in see here, apart from n, you are also passing a memo, and we are checking is the memo contains the answer for n. If it does, we don't need to calculate. We will just return from there. Line number 6, we will just straight up return from there. If not, then what we do is we calculate the result. Okay, and then what we do is store it in memo. That, hey, I have calculated it, I will store it, and later if I come with the same n value, I will use it. Okay, so this is how it works. This is how the memoization works. Tabulation is basically we create a table or grid or a matrix, and then we start from the smaller values, start from 0, 0, and then we start filling the values based on the previous cell in the matrix. Okay, so basically solve problems iteratively starting from the simplest case. If I is equal to 0, okay, here what happens in Fibonacci? If you have passed n is equal to 10, so 10 will call 9 and 8, then 9 will call 8 and 7, 7 will call 6 and 5, then 5 will call 4, 3, then 2, 1, and then 1, 0. But in tabulation, what we do is we start from 0, 1. 0, 1, then you fill the values for 0, 1, then 1, 2, then 2, 3, then 3, 4, and then 4, 5, then 6, 7, and then for 7 we give the answer. This is how the tabulation approach works. Okay. So that is to measure how it works. Okay, DP, dynamic programming, a basic intro of that. Okay, and here are a couple of resources I can give you. Very famous. These are all famous ones. I'll just copy this. 1 sec. I'll just copy and paste it in the chat. You can leverage it or search it. Okay, that's just 1 second. It might be some links. You can just search the name, it will work. Okay, I've just shared it in the channel. You can, if the link is not working, you can just copy the name which I have given you. You can just paste it on YouTube. Okay, and then you can find, or you paste it on the internet, and you can refer these resources for studying further. Okay, and yeah, I guess that's all of it. Yeah, thanks, and have a great evening to all of you. But after that, before leaving, okay, we'll have a quick Q&A. You can write your questions in the Q&A section. You can see this instruction. You can write your questions over there, and I'll be more than happy to answer. Okay. Yeah. Cool. Go ahead if you have any.
Yeah, everybody can write their question in Q&A. We will start taking one by one. Whatever questions you have, just write in Q&A. We will take it one by one. So those questions which will be common, we will like combine it. Everybody is able to find the Q&A. Can you give me a reaction? Like people are able to find Q&A. Okay, Vaishnavi, it's there only like on the corner. You will see like, just click on it. You will see like Q&A. Okay. So Prashant has question. Hi sir, what things to start with, recursion or DP?
So basically, you should always start with recursion. That is the foundation of DP. Okay, you start with recursion. Okay, and what will happen is you try to master recursion, and you understand why DP is required. I already gave the answer, but you try to understand on your own as well, actually by dry running and doing stuff, that why DP is required, and then you switch to DP. That is the perfect way to do it.
Okay. So we have a question from, wait a second, I'm just starting it up. Okay. Shiv is asking, every week you guys will conduct the DSA class. Yeah. So we are planning something to have like live classes on the DSA as well, but we will have every Saturday we have like workshops on various topics. You can keep on joining it. Okay. Govinda is asking, what is the Stack Overflow error more common in recursions than in loops?
Because why it is common? Because as I mentioned, one function calls another function, right? One function calls another function. So all these functions, function calls and variables are stored in the stack memory. And when you have infinite loop, then these functions are keep on overloading and just they fill the stack memory at a point, and the memory overflows. That hey, I had the storage of this much only, and you filled so many functions inside it. That's why it shows stack overflow error, and that's why it uses that. In for loop, it doesn't store the functions or something like that recursively functions in the stack, right? That's why it does not happen more in the loops. Yeah.
Okay, Prashant is asking any best source to practice coding.
Yeah, there are a couple of, if you are into competitive, my favorite site is Codeforces and AtCoder if you are into competitive. If you just want to do interview preparation and all of that, Geeks for Geeks and LeetCode is more than enough. Okay, so you can refer to that. And for opportunities, you can maybe, yeah, you can always open Cuvette and look for the opportunities over here.
Okay, everybody, are you able to find Q&A? It's in the corner only. On the corner of your screen, you will see triple triangle or triple dot from there, or multiple dots. Just click on it. You can add your question in the Q&A.
Yeah.
Pramod is asking, I'm literally understanding the concepts properly, but still bit confusion I got in finding power program. One more thing, I'm literally unaware about the Python syntax, but I'm efficient in Java as a fresher. Can I apply all the logics in Java?
Yeah, we can. So basically, I'm literally understanding the concept properly, but still little bit. Okay, power program. See, it happens. Okay, it's totally normal. You just go again, write how to find the power of a number. Okay, how to find power of a number or something like that on Google. You try to find the Java program. The logic remains the same in every language. It's just like we talk, right? So either I say you hello in Hindi, English, Tamil, Telugu, the meaning remains the same. That's how the logic remains the same. Programming languages can be different. I hope that answers your question.
Okay. Shiv Shankar, what happens if the base case is not defined properly?
If the base case is not defined properly, your recursion might, what your function would call infinite recursion. Okay. Or you might also get wrong answers. Mostly base case, not good base case results to infinite recursion. Okay, so it will cause infinite recursion or wrong answers.
Okay. Prashant is asking, can you add some platform in the chat to practice coding?
Sure, I can. 1 second. One second. And if you like, yeah, if you like, we can use this platform as well, AtCoder. Yeah, I have shared 3: LeetCode, GFG, and AtCoder.
Okay. Harshita is asking what kind of questions we can expect in interview from this topic.
Exact kind of questions I can't tell. It's very tough to tell what exact questions, but majorly questions will come. What generally they do is a recursion question where a follow-up question can be of BP. Okay, just like Fibonacci. In Fibonacci, the naive approach is to apply Fibonacci. But the interviewer can come ask you a follow-up question that now apply or reduce the time complexity. So all these kind of questions where recursion can, like DP can enhance the performance of a basic recursion code, that generally are asked. But it's very tough to select any 1 or 2 problems or kind of problems. This is a very important topic and you should go through all the questions in recursion as well as dynamic programming.
Okay, Ayush is asking, I have completed my first year experience, but I have been very reliant on GPT. Any advice for technical interview preparation? I know concepts, but cannot explain it.
Okay, that's a issue. I have been seeing this in a lot of people. For everything, they are using GPT and they have stopped learning actually. So that what you should do is for any technical interview prep or something, whenever you start practicing, okay, first 30 minutes you should focus and try to brainstorm any problem that has been given to you. Either it can be DSA or anything. Try to brainstorm and do not use GPT for that. Any problem, anything. Try to brainstorm at least 10, 15, 30 minutes. If you don't know the answer, then you can try for hints or something like that it is related to, but try avoiding that and try to use your own IQ and try to solve it. Yeah.
Okay. Going to the next question. Sachin is asking time complexity of recursive algorithm.
Time complexity of recursive algorithm is generally very bad, like n square, or it goes exponential also. It depends on the question, Sachin. It depends on the question, which kind of question you're solving. And the time complexity of that depends on the question, right? So it depends on that, yeah.
Okay. Kavya is asking, can you add that to visualization tool link in the chat?
Sure. I have added.
Okay. I think these kinds of tools, if you do like Google or if you ask ChatGPT, it will also recommend some tools. So don't worry about it. Govinda is asking, I am Golang developer, so is it a good choice?
Yeah, you can be Golang developer. It's a good choice. Go is a very fast programming language. Okay. For any company, what you need to have is, I'm talking about the product-based companies, what you need to have, and big startups as well, what you need to have is good DSA, system design, and CS fundamentals. Even if you are experienced, even if for freshers, DSA and CS fundamentals, these two carry the majority of the interview. In majority of the interviews rounds, these two will be asked. Okay, so yeah, it is good. You can be a Golang developer if you know all of the other stuff as well, and you're strong with that. That's completely fine.
Yeah. Fazil is asking, can a recursive function have multiple base cases?
Can a recursive function have multiple base cases? Yeah, yes.
Okay. Niamu is asking, I guess this concept is recursion tree, like start with top and end with bottom. And in DP, dynamic programming is like opposite of tree, like bottom to top. Am I right?
I guess this concept, just a second, top two and dynamic programming. See, recursion is some from big to small we go. But in dynamic programming also, I told you two approaches, memoization and another one is tabulation. In tabulation, we go from small to bigger numbers. The small cases we find, and then we go to the bigger ones. So yeah, you are correct, but yeah, memoization and everything that I told you, keep that also into consideration. Yeah, it's not exactly different, same as you have said. Keep that things also into consideration. Okay.
Okay, Ayush is asking, does Cuvette provide? Okay, just go and check our platform. You know, whatever companies are listed there, you can apply for internships. Pramod is asking, what is the worst case of recursive time complexity?
It also depends on the question. Okay, it can go exponential. It totally depends on the question.
Okay. Satyam is asking, can you please give an idea of how much DSA is needed for different tier of tech company? For example, FANG, service-based, basics like array string. See, for FANG level, you have to like go for like more competitive coding. For like mid-size companies, medium level DSA is good. If you have like medium level DSA understanding, that is like good enough to go for the mid-level companies, and below that as well. Zero DSA is not going to help you. If you are afraid of DSA, that without doing DSA you will get a job, it will not happen. You have to have like some understanding of DSA. Okay. Abdul is asking, in mutual recursion, can we use multiple base cases?
In mutual recursion, can we use multiple base cases? Yeah, we can. That also depends on question. Yeah, we can.
Good enough. So we have one more question. I have 1 year of industry experience and I'm actively applying for product. Where can I find company? I would suggest, Google these things, guys. If these are the questions which you are asking us, then there is no need of Google and GPT. Just type it that you are looking for company specific questions. You will get everything. These are very basic things which you are asking us. Okay, good enough. I think we are like okay, one more. Um, Anushka, I didn't get your question. Is it internship for MCA fresher? Dheeraj is asking what are the next week topics. The next week, probably we are going for generative AI in data science. We will talk about how the models are trained and we will go deep dive into technical aspects. We will get all the information. Sakshi, every week you guys will conduct the DSA class on Saturday. Not yet, but again, we will plan something like this. Do you want us to do it on every Saturday, like on a weekly basis? Do you want to do DSA classes? Can you just give a thumbs up or like reaction? How many of you guys wants to do like the regular DSA classes? Okay, okay. Most of the people want to take it. We will look at. Is there any planning for AWS? We will see. It will keep on coming. These workshops will keep on coming. ठीक है, great. Are the Sahana, are recursion and DP are only in high package? Come on, see, recursions and DPs are like, I would say, please understand these things that do not go for like only high package, low package interviews. It can be asked in low package interviews as well. Depends on interviewer, you know, which how much the competition is there. And that's what I'm saying. Mid-level DSA, you have to understand. Recursion is comes in the mid-level DSA, I would say. Okay. Okay, great. Thanks, guys. Thanks for joining. We will have more workshops every Saturday, more mentors coming from good companies who will, you know, interact with you guys. Will you will get all the session recording certificate on Monday, and we will share a feedback form as well. You can write your topics, like what topics you are interested in. We will see the DSA class planning. If we are able to do it, we will have a regular DSA session. Thanks a lot, everybody. Can you give like a heart reaction? Like if you love the workshop, can you give like a heart reaction to us? Everybody in the session, if you like the workshop, just give a heart reaction. Great, great, great. Thank you, guys. I'm just turning off.